In this class, we will show you how to use your FortiGate to troubleshoot misconfiguration and other network problems. Here's an overview of what we will discuss. We'll include baselining and monitoring your network, commonly used CLI commands, troubleshooting the physical layer, troubleshooting your IP network layer, the firewall session table, lack of resources, and hardware testing. After completing this class, you should have these practical skills. You should be able to determine your network baseline and read diagnostic output when your network's traffic volume or types do not conform to the baseline. You should be able to troubleshoot the physical and network layers, trace packet flow through FortiGate processing, and find the root causes of abnormally high CPU or RAM usage. Finally, you should be able to load a new firmware image for testing prior to upgrade. Before any problem happens, you should already know what the normal or baseline behavior of your network is. Administrators should know the expected range for CPU utilization, memory utilization, and traffic. We must also know, prior to any problem, how the traffic normally flows and what protocol and network applications are being used. Let's expand on that last point. How can studying diagrams, statistics, and reports help you to fix the network? Why should you determine and monitor your network's baseline? To find what is broken, it helps to know what is normally working and how. Before you study any other aspect of your network, you should first have a network diagram. This will help you to understand how traffic should normally flow in your network. When a network begins with only a few devices, explaining how it works is easy. But as it grows and becomes more complex into a larger enterprise-class network, and especially if more than one person is involved in network administration, then having a network diagram becomes essential. There are two kinds of diagrams, logical and physical. A physical diagram shows cables and ports on real appliances and their addresses on the network. A logical diagram shows all the various application processing and routing aspects. This includes VDOMs and VLANs. Again, the larger and more complicated the network, the more important both of these become. Depending on the nature of the problem, sometimes you need one or both diagrams. Knowing how your devices should connect isn't the only important thing. If, for example, one day your boss complains that email is slow and you log in and notice that the CPU is running 75%, how do you know if there's been a security breach or malfunction, or there's a temporary issue, or if you just need to upgrade some equipment? You need to know what the usual CPU level is. If normal is 69%, then 75% is probably still normal. But if normal is 12%, there may be a problem that requires your intervention. If your users comment that the network is slow, it may be due to a normal periodic backup job. But if you haven't been monitoring traffic and you don't know what the normal range is, you don't know if it's abnormal or not. Some of the well-known tools commonly used for network monitoring are SNMP, logging, and in the case of Fortinet devices, FortiAnalyzer. But there are many specialized third-party tools. What is the most basic way to check the system status? Get system status. This output shows the firmware version, operation mode, HA status, and versions of the antivirus and IPS databases. It also displays the system time and amount of VDOMs configured. It's a good initial general-purpose diagnostic. The system status includes the CPU usage. A few tools exist to monitor CPU usage. The most proactive option is via SNMP. This allows you to almost instantly receive traps for the current CPU levels. Every 5 minutes, FortiGate creates a performance log with some statistics about the device at that moment. These can be checked on the FortiGate or via FortiAnalyzer and syslog. On the dashboard, there is also a CPU gauge, and there are a few CLI commands too. For RAM levels, again, the best method of active monitoring is through SNMP, which allows you to monitor the level as well as set a trap that will trigger upon high memory usage. The event logs have details about the memory level, and so too the dashboard gauge. The CLI has several diagnostic commands that can be used to examine memory usage too. Packet capture is introduced in the firewall policy class. There are 2 additional advanced options that can be used. Count, which is the number of packets to capture. TS format, which is the format of the timestamp. Some timestamps aren't compatible with the Wireshark analyzer, for example. Here's a look at those options in action on a packet sniff. The first sniff shows a regular sniff. The second one is using these new options explicitly. In both cases, we're looking at a single ping being made to a remote destination. The first sniff command didn't specify a packet count, so it will sit here forever until you manually interrupt it or disconnect your management session. When it was stopped, it showed 4 packets. The second command was stopped automatically when the counter hit 3 packets. The difference obviously is that we don't quite see all the traffic. So in this case, the count was set too low and should be adjusted. A very useful command to set up an automatic sniff that you want to have stop eventually. Next, we'll look at the timestamps. The first one didn't specify an option, so the time is based on when the sniff started. From the output, this ping happened about 2 seconds after the ping was started. The second command uses an L, so it shows a time and date. We know the sniff was done on March 14, 2014 at 10:28 a.m., assuming the device had its clock set properly. The CLI command diag hardware device info NIC shows the status of a FortiGate's physical network interface. Depending on the model and the network driver, the information varies. But it basically displays the amount of packets and bytes received and transmitted, as well as the amount of physical errors detected. It also shows the logical state of the interface, up or down, link speed, and duplex mode. Sometimes slowness can be caused by a link speed mismatch between devices, so it's important to be able to find this information when necessary. These are the basic troubleshooting commands for testing network connectivity: ping and traceroute. You can change options for the ping command with the command execute ping-option. We can, for example, specify the source IP address of the ping packets, the number of packets to send, packet size, and so forth. FortiGate is a session-aware firewall, meaning that it tracks each conversation. Tracking occurs in the session table. FortiGate creates an entry in the session table for each conversation. Especially for large and active networks, the kernel session table is very large, so usually you should clear any previous filter setting with the command diag sys session filter clear, set a display filter with the command diag sys session filter, dport 80 for example. You can specify to omit only sessions that match a specific source or destination address or port, or those with a specific firewall policy. Alternatively, you can clear the session table, but be aware of the effects. This will remove those IP sessions from memory, so clients will need to reinitiate the session. Use the command diag sys session list. This is an example of a session table entry for TCP. We can see, for example, the TCP state, the remaining time to live, the characteristics of any traffic shaping being applied, counters, how NAT is done, including the NATed IP address, and counts for anything that may have been offloaded to another processor due to hardware acceleration. The session table contains information about each packet's protocol. This is shown by the proto equals field. The most commonly used ones are ICMP, TCP, UDP, and SCTP, and their protocol numbers are shown here. Each session has a state in the kernel. This indicates how FortiGate is handling the session. The session equals field contains various flags, such as whether or not it is logging this session, traffic shaping, and so forth. The NPU flag is critical in how FortiGate handles sessions. If it's disabled, the session isn't compatible with hardware acceleration by specialized ASIC chips, so it must be processed by the CPU, and the kernel will always be aware of those sessions. But if a session is offloaded, the NP or other chips maintain the session state almost the whole session. The kernel is only aware of the state at the beginning and end. This is discussed in more comprehensive detail in the hardware acceleration class. The session table also records the state of the TCP connections. There are two numbers: the state of the session between the FortiGate and the client, and the state of the session between the FortiGate to the server. This is because FortiGate terminates the TCP connection and makes a second connection to the backend server. If FortiGate proxies the traffic, these numbers can be different. But if it doesn't, then the first number will always be 0. We'll talk more about the expiry timer later. Although UDP is a stateless protocol, it doesn't inherently require confirmations of bidirectional connections like TCP. FortiGate also tracks UDP conversations in the session table. When FortiGate receives the first packet, it creates the entry and the state is set to 0. If the destination replies, the state changes and remains in 1 for the remainder of the conversation. Notably, ICMP, such as ping and traceroute, have no protocol state. SCTP sessions also have distinct states, so those are also separate. FortiGate will automatically remove IP sessions from the table after either TCP connection teardown when a proper FIN handshake is completed, session expiration, TCP connection timeout. The TTL is decided by the kind of traffic passing through the session, and it is a measure of inactivity. When was the last time the FortiGate saw a packet for this IP session? Expiration is decided based on the state of the session and determined by some CLI options depending on what type of traffic and/or what state the session is in. In the firewall class, we show diag, debug, flow, but it's useful for many traffic processing troubleshooting situations, including routing and UTM, because it not only shows ingress and egress, but it also shows why UTM decides to drop a packet. It's a multi-step command. Step 1. Enable packet flow output. Step 2. Specify a filter. Step 3. Start the trace. Step 4. Enable recording of the debug log. Step 5. Stop when you've finished. Something that has been mentioned already is memory and CPU usage. It's a good idea to gradually enable features as you need them. Don't enable everything at once. If the CPU or RAM usage is too high, and you've just enabled all or many features, it will be more difficult to determine the best way to lower system resource usage. When investigating very high CPU levels, always begin with both diag sys top 1 and get system performance status. When the CPU usage is high, diag sys top will no longer be accurate. If one of the proxies has a problem, then you can toggle inspection on or off with the diag test app command for that proxy by setting the flag to 5. For complex configurations, this is usually easier than trying to adjust the configuration while the CPU usage is high. If the source of the issue was in IPS, for example, then you could toggle inspection with this in order to immediately lower the CPU and then check logs and adjust settings in order to reduce inspection workload before re-enabling IPS. This can really reduce impact while you troubleshoot and provide some immediate relief if you have hundreds of firewall policies. It only turns off inspection, so anything else the process does will remain unaffected. The command get system performance status is used to display the CPU and RAM usage. It also displays the amount of average traffic sent and received by the FortiGate. At the top, there is CPU information. In this example, the output obviously came from a FortiGate that has a multi-core CPU because there are entries for CPU 0 to CPU 3. At the bottom, there is output for network traffic. You can use that to see if traffic is increasing, decreasing, or remaining steady. Here is the output for diag sys top. At the top, overall CPU and RAM usage are shown. Next, the top X processes are listed depending on the flag you entered. User space represents the resources being used for inspection, like antivirus scans, whereas system space relates to the amount of resources being used for operating system activities, such as routing traffic and reading or writing files. This information is essential to understanding all of the other system usage statistics and your baseline. Previously, we showed a column for process state. Here are the various options for the process state and how they correlate to the output shown. 98% of the time, the process state will either show R or S, which means it is actively doing something or waiting to be told to do something. Occasionally, you may also see D state processes, which generally are the ones that write information to hard drives. Obviously, if the process is regular in the D state or stuck like that for an extended period of time, this could mean that there is a problem reading or writing to that device. You'll probably never see a process in the Z state, but that's a zombie process and it means the OS has encountered an error it can't proceed from. Only a reboot can flush it out. Diagnose sys top can also be used to look at memory usage, not just CPU levels. It can be useful when an individual process is consuming too much RAM, but the OS itself will use RAM too. There are some additional commands that can be used to find this type of memory usage. Here is a comparative look at the output from diag sys top and diag sys summary. You can see the output is very different. In the diag sys top output, processes are listed multiple times, but in the diag sys top summary output, they only are listed once. An X appears when a process is forked multiple times. Process forking happens when the operating system spawns multiple copies of a process in order to either subdivide processing load or handle tasks that require division. Diag sys top shows the individual processes, but diag sys top summary collapses the processes and calculates total CPU and RAM usage of all the child processes. If we go back and look at output for a minute, diag sys top shows scan unit D running 3 times, diag sys top dash summary shows one entry with an X3, meaning it was forked 3 times. But diag sys top summary shows that scan unit D is using 12 megabytes of RAM, while Diagnostics top indicates that scan unit D should be using just under 2 megabytes. What is causing this difference between the two? The antivirus database, which is loaded into shared memory rather than as a duplicate. Operating systems don't allow different processes to communicate directly, so if memory wasn't shared, then copies of the database would need to be loaded into memory again for each process. From the output, the database used here is about 10 megabytes, so that would mean each individual process would be using around 11 megabytes and increase memory usage for antivirus scanning to about 33 megabytes. Either that or the entire database would need to be passed through the operating system stack. Here shows another command that shows the overall memory on the FortiGate. At the top, the memory usage levels are shown. Below this, you can see an analysis of the memory usage. Different models will obviously have different values since RAM varies by model. This shows the shared memory diagnostic. It provides a quick summary of how much shared memory is being used on your FortiGate. This can be useful to determine if your FortiGate is actually in conserve mode or not. Creating a log entry takes up memory. While in conserve mode, FortiGate is doing everything possible to prevent RAM usage from increasing. Trying to create a log entry while conserve mode is active would be counterproductive. Diagnose hardware system slab shows memory allocation for the kernel. Note that this is a very low-level look at the device. It is not likely to make sense unless you have an in-depth OS knowledge. For example, there is an entry for inodes, which are essentially pointers for file handles. A large number there indicates that there are an abnormally large number of files open by the operating system. So while this may not directly help you to troubleshoot, it can be useful in rare cases with Fortinet technical support. Rather than simply installing a new firmware image, you can use the console to temporarily load a new firmware image for testing before you upgrade. New firmware can contain new features that change the original behavior. If your network depends on a previous default setting, for example, this can require that you adjust the configuration, but until you discover this, will traffic flow be broken? If you upgrade, for example, from FortiOS 4.3 to 5.0, you can use this feature in order to load the new firmware and try it out before actually saving it to your FortiGate's disk. This way, if you discover upgrade issues, you can simply reboot and FortiGate will revert to the previous firmware and configuration while you plan your migration strategy. You can also use this feature to load special HQIP software that can diagnose hardware problems. If you suspect a hardware problem, Fortinet has a website that contains an image which we use in order to test the hardware. There's a basic test image, an advanced test, which we recommend for processing an RMA, a drive testing image, and flash testing image. If your FortiGate is crashing or experiencing erratic issues that can't otherwise be explained, you can format your FortiGate and test it to see if there is a hardware failure. Failure of RAM, for example, like with any other electronic device, can cause intermittent symptoms. To temporarily load a firmware image or diagnostic software, you must connect through the console port, not to the GUI, and not to the CLI through SSH or Telnet. Temporary firmware is loaded by interrupting the normal boot up, where the bootloader loads the OS from disk. Instead, you will tell the FortiGate to load an image from a TFTP server on the network. Here is the text-based menu that appears on the local console when FortiGate is rebooted. After some initial information about itself first, the FortiGate model, serial number, and so forth, then FortiGate shows an option to interrupt the boot process by pressing any key. This displays a boot options menu. Assuming the hardware test is okay, You would then format the FortiGate in order to do a clean install of a fresh firmware image, after which you can restore the configuration you have backed up. The very last question it will ask you once the image has been loaded and verified is if you want to save this as the default or run it. If you choose default, that's the image the FortiGate will use every time it boots up. If you select run, then the FortiGate will use that image until it is power cycled. For any of the diagnostic images, choose the run option and wait. All of the diagnostic images will run their tests and reboot, returning the FortiGate to its normal firmware. You can also use this method for testing new firmware images and patches. You can load the image this way and not have to worry about any incompatibilities with your network traffic. Simply power cycle and things are back to normal. If you're running a test, make sure you're saving the output to a file just in case support needs it in order to authorize an RMA or something. A format clears all the memory partitions on the device.